Have you ever gazed up at a bird soaring effortlessly through the sky? Or perhaps been captivated by the incredible agility of a racing drone zipping through an obstacle course? There's something truly mesmerizing about witnessing flight, a sense of freedom and wonder that sparks the imagination. And as you watched, did a thought ever cross your mind? A little voice whispering, "I want to do that." The desire to not just observe, but to participate, to create something that defies gravity and dances in the air. What if you could not only join the world of drone enthusiasts, but actually build your own high-performance flying machine? A personalized creation tailored to your specific needs and aspirations. Imagine the satisfaction of piloting something you brought to life with your own two hands. What if you could accomplish this amazing feat right in the comfort of your own home, transforming a spare room or garage into your personal drone-building headquarters? No need for fancy labs or expensive equipment, just a dedicated space and a passion for innovation. Building a drone isn't just about snapping pre-made parts together like a simple model kit. It's a journey of discovery, a chance to understand the intricate workings of a complex system. It's hands-on science, a practical application of physics and electronics that brings textbook theories to life. You'll be soldering wires, calibrating sensors, and experimenting with different configurations to achieve optimal performance. It's engineering, a process of problem-solving and creative design where you'll learn to optimize weight distribution, aerodynamic efficiency, and structural integrity. And above all, it's pure fun. A rewarding experience that combines technical challenges with the thrill of creation. There's nothing quite like the feeling of seeing your vision take shape, piece by piece, until it's ready to take to the skies. You'll gain an intimate understanding of how every single piece works, from the smallest resistor to the most powerful motor, and how they all interact to create a cohesive flying machine. You'll delve into the world of motors, learning about different types, their power output, and how they translate electrical energy into rotational force. And you'll explore the intricacies of the flight controller, the computer brain that orchestrates the entire flight, processing sensor data and making real-time adjustments to keep your drone stable and responsive. And you'll experience the unparalleled feeling of real victory when your creation finally lifts off the ground, soaring through the air with grace and precision. It's a moment of pure triumph, a testament to your hard work and dedication. Don't worry if you're not a seasoned engineer or a tech whiz. This journey is designed for everyone, regardless of their prior experience. I'll guide you step by step through the entire process, providing clear and concise instructions, helpful tips, and troubleshooting advice along the way. Carefully selecting the right parts for your specific needs to mastering the art of troubleshooting and debugging. I'll be there to support you every step of the way. By the end of this adventure, you'll not only have a killer drone that's ready to take on any challenge, but also a brand new set of valuable skills that will empower you to tackle any technical project with confidence and creativity. So, are you ready to embark on this exciting journey and build something truly amazing that flies? Let's gather our tools, organize our workspace, and get started on this incredible adventure. The sky's the limit. Before building, let's get our essential tools together. You'll need a quality soldering iron, lead-free solder, and a cleaning sponge. Grab hex drivers, 1.5mm, 2 mm, 2.5 mm, a small socket wrench, wire cutters and wire strippers, a helping hands tool, double-sided tape, zip ties, and heat shrink tubing will make assembly easier and safer. Don't forget a digital multimeter for troubleshooting and safety glasses for protection. Work on a silicone soldering mat to keep things organized and safe. A smoke absorber or fan helps with fumes. With your workspace set, you're ready for a smooth, stress-free build. Time to pick your drone's core components. Start with a carbon fiber frame, strong, light, and perfect for agility. Choose 4 motors, 2300-2700 kV for a 5-inch build, and matching propellers. Each motor needs an ESC, either 4 singles or a 4-in-1 board for simplicity. The flight controller is your drone's brain. Pick one with modern firmware like Betaflight. Many FCs and 4-in-1 ESCs have built-in power distribution, making wiring easier. With the right parts, you're set for a high-performance build. Alright, let's dive into assembling the frame, the very foundation of our drone. This is where we transform a collection of parts into a cohesive structure, the skeleton that will support all the electronic components and enable our aerial adventures. Take a moment to familiarize yourself with all the frame components. Understanding how each piece fits together is crucial for a smooth and successful build. We'll be working with carbon fiber, known for its strength and lightweight properties, making it ideal for drone construction. This frame is essentially your drone's skeleton. It's the backbone that provides structural integrity and houses all the vital components. A well-built frame ensures stability during flight and protects the electronics from damage. Think of it as the chassis of a car. Everything else is built around it. We'll be meticulously assembling each part, ensuring a robust and reliable structure. Now, let's attach the arms to the bottom plate. These arms will eventually hold the motors, so it's important to ensure they are securely fastened. The bottom plate serves as the central hub, connecting all the arms and providing a mounting point for other components. We'll be using screws and a dab of blue thread locker on each screw to prevent loosening due to vibrations during flight. This is a critical step, as loose screws can lead to catastrophic failures mid-air. A small amount of thread locker goes a long way in ensuring a secure and reliable connection. Remember, safety first. Next, we'll build the main body using standoffs. These standoffs create vertical space within the frame, allowing us to stack and organize the electronic components neatly. They also help to isolate the components from vibrations, further enhancing the drone's reliability. It's important to note that we shouldn't fully tighten everything just yet. Leaving the screws slightly loose allows for some flexibility during the subsequent installation of electronic components. This will make it easier to align and adjust everything as we progress. Once the frame is solid and all the components are aligned, we can go back and fully tighten all the screws. This will ensure a rigid and robust structure that can withstand the stresses of flight. Double-check each screw to make sure it's properly secured. Now, let's mount the 4 motors on the ends of the arms. These motors are the powerhouses of our drone, providing the thrust necessary for lift and maneuverability. Ensure that each motor is securely attached to the arm. Again, we'll be using the correct screws and applying more thread locker to prevent them from loosening. The vibrations from the motors can be quite intense, so thread locker is essential for maintaining a secure connection. It's crucial to ensure that the screws aren't too long, as they could potentially damage the motor wires. Carefully check the screw length before tightening them down. Damaging the motor wires can lead to short circuits and motor failure. Pay close attention to the orientation of the motors. We want the wires to point inward towards the center of the frame. This will help keep the wiring neat and organized, preventing them from getting tangled or interfering with the propellers. Motor direction is extremely important. You'll need to follow your flight controller's diagram to ensure that each motor spins in the correct direction. Incorrect motor direction will result in the drone being unable to fly properly. The diagram will specify which motors need to be clockwise, CW, and which need to be counterclockwise, CCW. This configuration is essential for maintaining stability and control during flight. As before, leave everything slightly loose for now. This allows for adjustments later on when we install the electronic components and route the motor wires. You'll tighten everything up after the electronics are installed and all the wiring is properly routed. This ensures that everything is perfectly aligned and secure before we take to the skies. This sturdy frame, complete with motors, is now ready for the next stage of the build. We've successfully assembled the drone's skeleton, providing a solid foundation for the rest of the components. Now, let's move on to the exciting part, installing the electronics. This is where we bring the drone to life, giving it the brains and nervous system it needs to fly. We'll be working with components like the flight controller, ESCs and receiver, so get ready to dive into the world of drone electronics. Time to install the ESCs and flight controller. Mount a 4-in-1 ESC board in the central stack, using nylon standoffs to avoid shorts. If using individual ESCs, secure one to each arm and solder their wires to the motors. Mount the flight controller above the ESC, ensuring the arrow points forward. Connect ESCs to the FC, either with a harness for 4-in-1 or by soldering signal and ground wires for individual ESCs. Double-check connections and orientation before moving on. Now, let's wire up the power and electronics. Solder the XT60 battery connector to the main power pads. Double-check polarity to avoid frying your gear. Tin wires and pads before soldering for strong joints, and insulate with heat shrink. Connect your radio receiver to the FC's UART pads, power, ground, signal. Solder FPV camera and VTX wires to their designated pads. Use zip ties for neat, secure cable management. Keep wires short and away from props. Clean wiring isn't just pretty, it's safer and easier to troubleshoot. With everything connected, your drone is nearly ready to fly. Time for final assembly. Attach the top plate, securing it with screws and thread locker. Don't pinch any wires. Install propellers, matching each to the correct motor direction. Secure props with lock nuts, but don't over-tighten. For setup, keep props off for safety. Strap the LiPo battery tightly to the frame. A loose battery is dangerous. Use only undamaged LiPo batteries. Charge with a proper balance charger and store in a fireproof bag. Never leave charging batteries unattended. Practicing LiPo safety protects you and your drone. With these steps, your drone is ready for pre-flight checks. Before flying, connect your drone to a computer and open Betaflight Configurator. Flash the latest firmware, then calibrate the accelerometer on a level surface. Set up the correct ESC protocol and verify board orientation using the 3D model. In the Motors tab, test each motor's spin direction. Props off. Reverse any incorrect motor direction in software. Set up your radio controller, switches, and failsafe. Make sure all controls respond correctly. With everything checked, you're ready for your first flight. The big moment has arrived. It's time for your maiden flight. All those hours of building, soldering, and configuring have led to this. There's a unique thrill in seeing something you've created take to the skies for the very first time. Take a deep breath, try to relax, and let's get ready for this exciting milestone. First things first, find a large open field, far away from trees, buildings, power lines, and especially people. You want a wide open space that gives you plenty of room to maneuver and minimizes the risk of collisions or, worse, injuries. A park or a dedicated flying field is ideal. Make sure it's a day with calm winds for your first flight. Once you've found your safe haven, place the drone about 20 feet away from you. This gives you a buffer zone and prevents you from accidentally getting too close during takeoff. Ensure the drone is sitting on a relatively flat surface to avoid any unexpected tilting or wobbling during the initial moments of flight. Safety should always be your top priority. Double-check that your propellers are securely fastened, your battery is properly connected, and that you have a clear line of sight to the drone. It's also a good idea to have a spotter with you, especially for your first few flights. Now, arm the drone. This usually involves a specific stick combination on your remote controller, as configured in your flight controller software. Listen for the motors to initialize, indicating that the drone is ready to fly. With a steady hand, gently raise the throttle. Increase the throttle slowly and deliberately, paying close attention to how the drone responds. Avoid any sudden or jerky movements. Watch carefully for a smooth and controlled liftoff. The drone should rise steadily and evenly, without any erratic movements. If everything looks good, continue to increase the throttle until the drone is hovering a few feet off the ground. However, if the drone flips, wobbles violently, or acts in any way that seems out of the ordinary, disarm the motors immediately. This will prevent any further damage to the drone or potential injuries. After disarming, carefully inspect the drone. Start by checking the motor direction. Ensure that each motor is spinning in the correct direction, as indicated by the arrows on the motors or the flight controller diagram. Verify the FC orientation. Make sure that the flight controller is mounted in the correct orientation within the drone frame. The arrow on the flight controller should point in the intended forward direction. Double-check the prop placement. Ensure that each propeller is installed on the correct motor and that the propellers are facing the correct way. Incorrectly installed propellers can cause the drone to behave erratically or even crash. If the drone successfully hovers, congratulations! You've overcome the first major hurdle. Now, take some time to practice gentle hovering. Get a feel for how the drone responds to your inputs. Try to maintain a stable hover at a consistent altitude. Once you're comfortable with hovering, start practicing basic controls. Gently experiment with pitch, roll, and yaw to get a feel for how the drone moves in each direction. Start with small, controlled movements and gradually increase the intensity as you gain confidence. When you're ready to end your flight, carefully bring the drone back down for a landing. After landing and disarming the drone, check the motor temperatures. Excessively hot motors can be a sign of a problem, such as over-tightened props, incorrect motor timing, or damaged bearings. If a motor is too hot to touch, investigate the cause before flying again. If you notice that the drone drifts in one direction or shakes excessively during flight, it may be necessary to recalibrate your sensors or adjust the PID settings in your flight controller software. PID tuning can be a complex topic, but there are many online resources and tutorials available to help you get started. Remember that troubleshooting is an inevitable part of the drone building journey. Don't get discouraged by setbacks. When troubleshooting, it's crucial to change only one thing at a time. This allows you to isolate the cause of the problem and avoid introducing new issues. With each problem you solve and each adjustment you make, you're becoming a better builder and a more skilled pilot. So, embrace the learning process, enjoy the challenges, and celebrate your successes. Welcome to the sky, where the possibilities are endless and the adventures are just beginning.